Hello, very good morning to all of you. Welcome back to the video lecture series. Dear friends, we are discussing here the protein characterization topic from the food analysis section of CHA 393B. Okay, so in this section we have, in this chapter we are discussing the different characterizations of proteins in the food products. Our today's topic is assessment of protein functionality properties. Assessment of protein functional properties. So first of all, we will see what is meant by protein functional properties. Okay, so the protein functional properties can be defined as these are the physical and chemical properties of protein molecules. These are the physical and chemical properties of protein molecules that affect their behavior in food products during processing, storage and consumption. During processing, storage and consumption. Okay, so this is the definition of protein functional properties. So the different functional properties of proteins are important from their behavior point of view in the food material. Okay, so these functional properties of proteins have a very simple definition, that is, this is the physical and chemical properties of protein molecules. Okay, both physical and chemical properties that affect these chemical and physical properties affect the behavior of these proteins in the food products during processing, storage and consumption. Out of the different physical and chemical properties, the three main functional properties of proteins are solubility, then emulsification and foaming. Okay, so solubility, emulsification and foaming, these are the three main important properties of protein that affects their behavior in the foods or food products. Along with that, the two subsidiary properties are there for proteins, and these are gel formation and dog formation. Gel formation and dog formation. Okay, so we will see in today's lecture, we will see the first two important functional properties of proteins, that is solubility and emulsification. So what is meant by solubility? We know that solubility of any component or any solute is nothing but amount of one solute, amount of one substance dissolved per 100 gram of solvent. Per 100 gram of solvent. We express this as a percent solubility. We express this quantity as a percent solubility. Means what? If we have 1 gram of sugar and 100 gram of water, and we know that the sugar and salts are completely soluble in water, so that's why we call it as a percent solubility. Okay, so how much amount of that sugar is get soluble in a given amount of solvent? So here the sugar and salts are 100% soluble, so we call that the sugar is having 100% solubility in a given amount of water. Okay, so this is the nothing but concept of solubility. Here the principle of this solubility topic, solubility property of the protein is, this is most important and most popular test for protein functionality. For protein functionality, we have to consider this solubility is one of the important property, one of the important and most popular test. Okay, means while testing this solubility is also one of the factor for the proper functioning of the protein molecules in food products. The proteins need to be soluble under conditions of use for optimal functionality in food. Means for the proper functioning, for optimum use and optimum functioning of that protein molecules in the food products, these proteins must be or need to be soluble at a given conditions or at a under conditions of use. Means what is the condition of use, what is the condition of storage, what is the condition of consumption, that are called as under conditions of use for optimal functionality of that protein. Now this solubility of these proteins depends mainly on the balance of hydrophobic and hydrophilic type of amino acids that make up the protein. Means we know that proteins are made up of hydrophobic and hydrophilic different types of amino acids. Some of these amino acids are hydrophobic in nature, means they are water repelling, and some of these amino acids are water attracting. We call them as a hydrophilic amino acids. So the balance of these two, hydrophobic and hydrophilic amino acids, is responsible for the solubility of that protein in a given solvent or solution. Generally it is water. Okay, then the solubility also affected by the thermodynamic interaction between protein and solvent. Okay, so thermodynamic interaction between that protein and solvent, these thermodynamic interactions are also responsible for the solubility of protein. Then the next one is different parameters of solvent, such as polarity of solvent, whether it is polar or non-polar. Okay, we know that the water is polar solvent and oils are non-polar solvents. Okay, so solvent polarity, then pH of the solvent, then ionic strength of the solvent. Okay, these factors or parameters of the solvent also affects the solubility of protein. Along with that, interaction of that solvent and protein with lipids and carbohydrates. So lipids and carbohydrates are the other components of the food material that we know. Okay, so the interaction of these proteins and the solvent with the different food components such as lipids and carbohydrates, this is also one of the important factor for the solubility of protein. Now the procedure for percent protein solubility, the procedure for determination of percent protein solubility is very simple. Just we have to add a protein sample into a water or buffer solution. Okay, so dissolve that protein sample into a water or buffer solution at specific pH. Okay, because pH is very important case here, as we know that amino acids are the building block units of proteins, and these amino acids are very sensitive to the pH value. Okay, acidic or alkaline, so that's a specific pH should be considered. And after dissolving this protein sample into a water or buffer, we have a dispersion, or we have a dispersion solution. Means that protein is get dispersed into that water or buffer solution. Then this dispersion is centrifuged. We have a centrifugal machine, and this dispersion medium, okay, containing protein and the solvent, water or buffer solution, is get centrifuged with the help of centrifuge machine. Okay, and after that what will happen? The dissolved protein, some amount of that protein is get dissolved into the solvent, that is water or buffer, and some of the protein part is get collected at the bottom of that sample holder in the centrifugal machine. We call it as a centrifugate. Okay, this is called as non-soluble part, which is get solidify at the bottom of that solution or dispersion, and the dissolved protein will be in the form of supernatant solution, which is above that solid part present in the sample holder in that centrifugal machine. Okay, so we have two parts, that is solid part and a supernatant solution in which the protein is get soluble. Okay, now we have the soluble part of that protein in our supernatant solution. So we have to determine the protein percentage of protein or the amount of protein that is dissolved in the that buffer or dispersion water solution. Okay, and that can be determined by using Geldahl method. We have already studied this Geldahl method. By using Geldahl method or Bradford method or BCA method, okay, studied by us in the previous lectures. Okay, so we have to determine the content of that protein by Geldahl method or Bradford method or BCA method. Okay, then the percent protein solubility can be calculated by using the formula soluble protein divided by total protein into 100. Soluble protein in the supernatant solution divided by total protein. Total protein is given by the protein in the soluble part plus protein in the insoluble part, that is in the centrifugate. Okay, so the ratio of these two is multiplied by 100. This will gives you the percent protein solubility. Okay, so this is all about the solubility functional properties of protein. Now the second one is emulsification. Now what do you mean by emulsion or emulsification process or emulsifier? These terms are new to us. So in simple words, we can say that what is meant by emulsion? Emulsion is nothing but a mixture of two immiscible liquids. A mixture of two immiscible liquids means when we add water in oil or oil in water, then the mixture of these two is called emulsion. Okay, but scientifically saying, when droplets of one immiscible liquid enters into the another liquid, then that phase or that medium is called as emulsion. Just imagine we are adding some amount of oil in water. Okay, then the oil droplets may enter into the water solution. It is nothing but emulsion of that oil and water. Now there are oil and water. This is one of the important and most commonly occurred emulsion found in the food products. Most commonly occurred emulsion is found in the food products. Okay, and this emulsion must be preserved. This emulsion of oil and water must be preserved in these food products, because if water and oil is get separated from any food material, then that food material or that food product may undergo decomposition. Okay, or the homogeneity of that food product may undergo loss. So that's why this emulsification process must be done for any food product, and we know that the different examples are there for the different examples are there for the different emulsions in the food products, that are margarine, okay, that is vanaspati ghee, butter, milk, cream, cheese, etc. So all these are nothing but different milk and milk products. Okay, so all these are nothing but the examples of food emulsions that are encountered in the food industry. Okay, so what is emulsion? Mixture of two or more immiscible liquids. Mixture of two or more immiscible. Immiscibles means they are not miscible with each other, just like water and oil is a best example. Okay, two or more immiscible liquids, one of which is dispersed as droplets in other. One of the immiscible liquid is dispersed as droplets of one liquid into other liquid. So this mixture is called as mixture of two immiscible liquids is called as emulsion. Okay, so this oil and water is the common emulsion in food products that we have also seen. So these droplets in water, so the water droplets of oil in water, they are known as, or they are called as, collectively they are called as dispersed phase. They are called as dispersed phase or discontinuous phase. Dispersed phase or discontinuous phase. And the liquid which is present in larger amount is called as continuous phase. Is called as continuous phase. Okay, so sorry, actually they are forming one of the type of colloid. So colloidal material or colloidal type of material can be formed during this emulsification or emulsion formation. Okay, now why we are studying this emulsification property of this protein? Because I have already told you that when we are making different food products, the oil and water must not be separated. Say for example cake, we are making a birthday cake, and in that birthday cake both oil and water are used for the preparation of that cake material. If from that cake product oil and water is get separating, then it undergo decomposition, or homogeneous nature of that cake may collapse. So that's why the emulsion must be there. Emulsion of that oil and water must be preserved, must be stored, must be maintained during the storage and consumption, during the processing, storage and consumption of that food product, and hence the emulsification process must be considered here. And why we are studying here? Because our proteins are acting as a emulsifier agent. They are acting as a emulsifying agent for this emulsion in the food products. Okay, so what is meant by emulsifier? Emulsifier are the agents or the materials or the substances which are responsible for the maintaining, storage and maintaining of that emulsion for a longer time. So these substances preserves that emulsion for a longer time, for a storage for weeks, months, etc. And this preservation of the emulsion is also maintained during processing, storage and consumption of that food products. Okay, means what? When we are storing that cake, our cake material in the bakery shop, okay, so no doubt we know that the cake remains as it is for 2 to 3 days, for a week, etc. Also during consumption of that cake, the water and oil also does not get separate. Means what? Why it is so? Because emulsifying agents are used in that bakery products. Okay, so that's why the homogeneity or the preservation of emulsion has been take place there. And why we are studying here? Because our proteins are acting as emulsifier in that milk and bakery products. Okay, so proteins as emulsifiers. Why or how they are acting as emulsifiers? They lowers the interfacial energy between phases to facilitate emulsion formation and improve stability. So we know that the oil droplets are entering into the water, and there is a phase boundary, there is a phase boundary such as, so these are the oil droplets, let us say, and this is a water, let us say. Okay, so this is a water, let us say, and these are the oil droplets present in that continuous phase, that is water or buffer solution. Okay, so there is a boundary, so these are the oil droplets and this is the boundary, we can say, between this oil liquid and water liquid. Okay, and these proteins, what does they do? They lowers the interfacial energy. So this is the interfacial, facial means face, interfacial energy between this liquid oil and liquid water. So the energy between these two is get lowered by these proteins between phases and to facilitate emulsion. So when these energies get lowered, emulsification process is get facilitated. Emulsification process is get facilitated and it improves the stability of that emulsion. So stability of that emulsion is get improved and we require the same, we are needing in the same, we should improve the stability during storage and consumption of that emulsion. Okay, another important factor is that these protein molecules migrate to surface. These protein molecules migrate to the surface of that droplets, to the surface of that droplets. They forms a protective cover, protective layer, or we can say a membrane around that oil droplets in the water. Okay, and hence decreasing or reducing the interactions between the two immiscible phases. So two immiscible phases are there, oil and water. So the protein molecules are decreasing the interactions between these water and oil. Okay, and ultimately it improves the stability of that emulsion. Okay, now different procedures have been put forth by the different group of scientists, but some of these are discussed here. The procedures for emulsifying ability of that protein can be estimated by droplet size of dispersed phase. So this is a dispersed phase and this is continuous phase. Water is a continuous phase here and oil's droplets are dispersed or discontinuous phases. Okay, so the size, water droplet size is important factor that is utilized here for the emulsifying ability of that protein. Okay, so droplet size of dispersed phase determined by turbidimetric technique. So turbidimetry, we know that turbidimetry technique, and this turbidimetry technique is useful for the water droplet size estimation. Okay, then another technique is that microscopy, then laser diffraction technique is there. Okay, so these techniques, turbidimetry, microscopy and laser diffraction techniques are used for the estimation of water droplet size. Okay, and from that we can determine the stability of that emulsion and ultimately the ability of that protein for the emulsification process. Okay, the emulsion stability can also be estimated by centrifugation or agitation. Centrifugation or agitation, both terms are known to us, and the time to determine amount of creaming or oil separation has been determined. Time to determine amount of creaming, cream is nothing but oily part, oil or oily part of that emulsion. Okay, to separate out that oily part or creamy part of that emulsion from the continuous phase, that is from water or buffer solution. Okay, this time is determined by using centrifugation or agitation method, and this is nothing but used to evaluate or to estimate the emulsion stability. Okay, so I think you got it, the emulsification and solubility concept of this protein assessment functionality properties. Okay, so thanks for watching this video. Have a nice day.